Hello and welcome to 10th set of problem of arithmetic progression, geometric progression and harmonic progression. In this set we will solve problem number 91 to 100. So as always I will say that before seeing the solution you should pause the video when the problem is being stated and should try to solve the problem yourself. If you cannot solve the problem yourself, only then look at the solution. So without further delay, let's get started. Problem number 91 says that one side of an equilateral triangle is 24 centimeter. The midpoint of its sides are joined to form another triangle, whose midpoints are in turn joined to form still another triangle. The process continues indefinitely, finding the sum of perimeter of all the triangles. So perimeter of the first triangle would be 24 into 3, that is 72 centimeter. Now the triangle which we form by joining the midpoints of the first triangle will have sides of 12 centimeter, because if you see an equilateral triangle, you join midpoints, then the sides will be half. You can prove that by proving the similar triangle here. So the perimeter of second triangle, this is by spelling, triangle will be 12 into 3, that is 36 centimeter. And then for that triangle, third triangle will have 6 centimeter side. So the perimeter would be 18. So the sum of all such triangles would be perimeter. Sum of perimeter would be 72 plus 36 plus 18 plus 9 and so on. So this is a geometric progression with first term 72 and common ratio half. So it would be 72 by 1 minus half, which is equal to 144 centimeter. Problem number 92 says that a ball is dropped from a height of 900 centimeters. Each time it rebounces, it rises to two-thirds of the height it has fallen through. Find the total distance traveled by the ball before it comes to rest. So first time the ball will fall for 900 centimeters, then it will rise for two-thirds of that distance, and then it will again fall two-thirds of that. That is 2 into 900 into 2 by 3. So again it will rise and fall for two-thirds of the distance, which would be 2 into 900 into 2 by 3 whole square. So the process will go on infinitely. So our required sum would be 900 plus 2 into 900 into 2 by 3 plus 2 into 900 into 2 by 2 square by 3 square and so on up to infinity. So this is a series of geometric progression with the common ratio 2 by 3. So now you can also observe that 2 into 900 is 1800, that multiplied by 2 by 3 is 1200, and this 900 is separate. So 900 plus first term 1200 divided by 1 minus common ratio, that is 2 by 3, which is equal to 4500 centimeter. Problem number 93 says that a square is drawn by joining the midpoints of the sides of a given square. A third square is drawn inside the second square in the same way, and this process continues indefinitely. This is in bad spelling. If the side of the first square is 4 centimeter, determine the sum of the areas of all the squares. So suppose our outer square is ABCD, then the midpoints are joined and we form PQRS. Now, if you observe, say for example, ABC and PBQ, so the ratio of PB and AB is 1 is to 2, ratio of QB and BC is 1 is to 2, and angle B is common, so both the triangles are similar, and therefore AB is to PQ would be 1 is to 2. Now we consider the first square. In this case, AC would be square root of 2A, where A is the length of each side. So PQ would be half of that, that is A by square root of 2. So area of first square would be A square, area of second square would be A square by 2, because PQ is A by square root of 2. Similarly, area of third square would be A square by 4. So we add all that to infinity and we get the final sum as 2A square, which would be 32 square centimeter, because our A is 4 centimeter. Problem number 94 says that in an increasing GP, the sum of first and the last term is 66. The product of the second and the last term, but one term, is 128. And the sum of all the terms is 126. How many terms are there in the progression? So we let A to be the first term, R to be the common ratio, and we also let that there are n terms in the GP. Then the sum of first and last term is A plus AR to the power n minus 1, which is 66. The sum of second and last but one term is AR into AR to the power n minus 1 to n minus 2 is equal to 128. And the sum of series A into 1 minus R to the power n by 1 minus R is equal to 126. So we have three equations and three unknowns, A, R, and N. So it's a straightforward solution of three equations. So what we do is we multiply these two in the second equation. We get A square into R to the power n minus 1 is equal to 128. Now what we can do is we can examine this and we see that AR to the power n minus 1 is equal to 128 by A. So we take that and we substitute here. So this becomes A plus 128 by A is equal to 66, which becomes a quadratic equation, and we factorize that to get A as 2 and 64. Now if A is 2, then A minus AR to the power n is equal to 126 into 1 minus R from here. Now again we substitute AR to the power n minus 1 is equal to 128 by A, which is 128 by 2. Now 1 R will remain here. So we get R is equal to 2. We follow the same principle for 64, we get R is equal to half. So our GP is increasing, which is given that GP is increasing. So A will be 2 and R will be 2. R cannot be half because GP is increasing. So once we have A and R, we can find out to be 6. Problem 95 says that the sum of an infinite GP is 2. The sum of the GP made from the cubes of the terms of this infinite series is 24, then find the series. So we let A to be the first term and R to be the common ratio. As always, we get A by 1 minus R is equal to 2. And sum of cubes of terms would be A cube by 1 minus R cube is equal to 24. So now it's a matter of substituting. So from first equation, A is equal to 2 into 1 minus R. So we substitute in the second. Becomes 8 into 1 minus R whole cube is equal to 24 into 1 minus R cube. Now you solve this, you arrive at a quadratic equation, you get R as minus 2 and minus half. But since it's an infinite GP, modulus of R would be less than 1, and therefore R is equal to minus half. And then we substitute this minus half over here, we get A is equal to 3. So our GP becomes 3, minus 3 by 2, 3 by 4, minus 3 by 8, and so on. Problem 96 is that the sum of an infinite GP is 3 and the sum of squares of the terms of this series is also 3. Find the sequence. So like previous problem, we have A by 1 minus R is equal to 3, A square by 1 minus R square is also 3. So we again solve the equation and we get R as half and we get A is equal to 3 by 2. So our series now this time is 3 by 2, 3 by 4, 3 by 8 and so on. Problem 97 says that if the sum of an infinitely decreasing GP is 3.5 and sum of the squares of its terms is 147 by 16, show that the sum of cubes of the terms is 1029 by 38. So we have A by 1 minus R is equal to 7 by 2, A square by 1 minus R square is equal to 147 by 16. So we solve it like previous problem, we obtain R is equal to 1 by 7. Once we have R, we have A will become 3, and once you have A and R both, you can compute the sum of cubes, which would be A cube by 1 minus R cube, which would eventually turn out to be 1029 by 38. Problem 98 says that find the value of x in minus pi, pi, which is an open interval which will exclude minus pi and pi, which satisfies the equation 8 to the power 1 plus modulus of cos x plus cos square x plus modulus of cos cube x up to infinity is equal to 64. So this is equal to 64. So we can write this GP as sum of GP as 1 by 1 minus modulus of cos x is equal to 8 square. So 1 minus modulus of cos x will become half. Thus cos x will become plus minus half, which gives us x is equal to n pi plus pi by 3, where n belongs to set of integers. So this actually requires a bit of knowledge of trigonometry. If you have not yet studied trigonometry, you can skip this problem and come back to this later. Problem number 99 says that if a is equal to 1 plus r to the power a plus r to the power 2a up to infinity, and b is equal to 1 plus r to the power b plus r to the power 2b up to infinity, prove that r is equal to a minus 1 by a whole to the power 1 by a small a is equal to capital B minus 1 by capital B whole to the power 1 by small b. So it's a very straightforward problem. A is equal to A is an infinite series with a common ratio r to the power a. So we can write A is equal to 1 by 1 minus r to the power a. From this, if you solve this, r will become capital A minus 1 by capital A divide whole to the power 1 by small a. Similarly, for second series, r would become capital B minus 1 by capital B whole to the power 1 by b. And since both are equal to r, we can prove the equality. We have proved the equality. Problem 100 says that if S1, S2 up to Sn are the sums of infinite geometric series whose first terms are 1, comma 2, comma 3 up to n and common ratios are 1 by 2, 1 by 3 up to 1 by n plus 1 respectively, then prove that S1 plus S2 plus 2Sn is equal to 1 by 2 into n plus 3. So in this case, S1 would be 1 by 1 minus half because first term is 1 and common ratio is half, which is 2. S2 would become 3 because first term is 2 and common ratio is 1 by 3. We follow this, we find Sn is equal to n plus 1. So we have 2 plus 3 up to n plus 1 as the sum of S1 plus S2 plus up to Sn. And then we apply the formula from arithmetic progression. We obtain the desired result as 1 by 2 into n plus 3. So with this, we come to end of 10th set of the problems, and we will further solve more problems on AP, GP and HP. If you found this video informative and useful, please subscribe to the channel and like the video so that the channel grows and more people get benefit from this. And if you have any comments or suggestions or you want videos on a certain topic, let me know in the comment box. I sincerely hope that you have enjoyed the video and learned something out of it. Thanks a lot for watching. Bye.